Hello, everyone. We just did trigonometry 008. Now I'm getting ready to do trigonometry 009, where we're going to derive the law of cosines, and then I'm going to give it to you in word form, but I'm also going to use it to solve a particular triangle. So you'll notice there's a little difference when we use the law of sines. It's when you have a side, then an angle, and then an angle, then a side, and then another angle. So the actual side is between the two angles, that's when you use the law of sines. But when you use the law of cosines, that's when you know two sides with the angle between them, or what they call the included angle. So keep that in mind. That'll help you know when to use what. So let me turn it over to my document cam. And I'm going to use what we got from the knowledge that we gained from doing the the unit circle, specifically that x is equal to cosine theta and y is equal to sine theta. But that was for a unit circle. It turns out for just any circle in general, x is equal to the radius of the circle times cosine theta, and y is equal to the radius of the circle times sine theta. You don't really have to know that right now off the top of your head. I'm going to show you how it works out. So let's imagine an XY plane like so. X really got bad really quickly. And there's my Y. And what I'm going to do is I'm going to put a oblique triangle on it. So I'm going to have an oblique triangle that has one side right here. And I'm going to call that side C. And that's a lowercase c, of course. Then I'm going to have a side here. And I'm going to call that side A. Again, lowercase a. And then I'm going to have side here that is B, and of course, again, that is lowercase b. When we have such a triangle, the angle opposite B would be big B, and the angle opposite C would be big C, and the angle opposite A, of course, would be big A. Now, in this case, I'm going to pretend like I know B, A, and C. Okay. So now what we would have done normally when I was deriving the unit circle is I would have taken this little angle right here and realized that if I take the cosine of that angle, then I'd get the y component over the hypotenuse. And of course, the y component was basically the y value. So y would equal 1 times the cosine of theta, and x would equal the negative of 1 times the sine of theta. Again, this being theta, the itty bitty angle here. But we're not going to do that. You could do that, and again, that ends up reversing the sines and cosines. But what we did learn is that the x coordinate is always going to be cosine of theta, only now instead of having a radius of 1, we're going to have a radius of b. So this point right here, that point I'll just call P1. That point's going to have a coordinate of b cosine A, because notice A is measured from the positive x-axis counterclockwise. And then, of course, it will also have a y of B sine A. So that's that point. This point, that focus is kind of bad. There you go, that's better. This point, obviously, starting from the origin here, this point is just going to be let's call that P0. That's going to have an x value of C and a y value of 0. And this point right here is just the origin. I'll call that P2, and that's just 0, 0. Okay, so now if I wish to know, for instance, the side A, I'd say A squared, using the Pythagorean theorem, sort of, A squared is equal to this x squared, which would be from here to here. And then this y squared right here. So a squared is equal to x squared plus y squared is what we're shooting for. Well, I think you can see what x is. X is going to be, oh, excuse me, I wrote that upside down. Let's make this one x. Let's make this one y. I don't know why I wrote those backwards, but this will fix it. Okay, so it's x squared plus y squared. The main thing is those make a right triangle, and that's why we can use the Pythagorean theorem. So I know that x, if I look at this, I can see that the x is this distance, which is c, plus this distance, which is b sine a. The y, which is this distance, is just b cosine A. So what I'm going to do is take the x, which is c, so that's from here to here, plus this, which is the x coordinate of this, which is b cosine theta. Ooh. And I should mention, remember, this is actually going to be a negative. So I should actually take that into consideration. It's BA cosine theta minus C if you want. So let's do it that way. I'm going to say X is going to be B cosine theta. That gives me that value minus C. So by doing that, it actually takes care of the sign issue. I could have done it the other way, but I have to manipulate the signs and put some minuses in there and stuff like that. Now the y, on the other hand, is just b sine A. So I'll say plus b squared sine A, or sine squared A. So we now have something we compute with. If I want to compute a binomial, remember it's the square of the first 2 times the product of the 2 plus the square of the last. So I'm going to get b squared cosine squared A. 2 times the product of the 2 would be negative 2 times b times c times cosine of A, and then plus the second term squared, so it'd be plus c squared plus b squared sine squared A. Notice the b squared cosine squared A and the b squared sine squared A can become just b squared sine squared A plus cosine squared A, which in our trig identities video, we found that this is exactly equal to 1, so that makes it easy peasy. So now I'm left with b squared and actually, there it is, plus c squared, which is that one right there. So I've now taken care of that term. I've taken care of this term, and I've taken care of that term. And then all I have left is minus 2bc cosine A. So ultimately, my results is a squared is equal to b squared plus c squared minus 2bc cosine of A. So the general rule is the square of a side is equal to the sum of the squares of the other two sides minus 2 times the magnitude of one times the magnitude of the other times the cosine of the included angle. So what that means is we can also do it for this one, in which case I'd say c squared is equal to, now c squared is this one. The two sides are a squared plus b squared. So c squared is up, c is up here. This is the side c. So c squared is equal to a squared plus b squared. Now I'll say minus, now I'll say 2 times the product of the 2, which is AB, times the cosine of the angle included between them. So it'd be cosine of C. Notice this is the same sign of that. That's a good rule of thumb to help you keep your wits about you when figuring out the law of cosines. Now, if I also wanted to do B, I could say B squared is equal to, now I'm looking at B, so the other two sides are A and C, so it's A squared plus C squared minus 2. Now I'd multiply the two sides, AC. Now I got to do the cosine of the angle between them, which is big B. So those are the 3 versions of the law of cosines. So remember, this is when you have a side angle side, whereas the other one, law of sines, was when you had an angle side angle. So this is side angle side, and the other one was, the law of sines was for angle side angle. So now that we have that, let me do one example. Let's take, for instance, the triangle that has b equal to 11. Now I don't actually have to give you the names, the signs, the actual symbols for these sides, but I'm doing it in this first case just to give you a nice introduction. Let's call this side C, and then let's call this side over here A. Okay, and let's say this angle is 112 degrees, which I think you should recognize is capital A. Now, in principle, I could just have a 20 here, 11 here, and a 112 there, and then you'd have to figure out all the rest, and that's really what you want to do. You want to be able to figure that out. Now, once I have this side, and that's what I'm trying to solve for, then I'll have all the sides of the triangle, and then I could have, I have side, angle, side, but in this side, in this case, I'd have basically I could maybe use this law of sines to figure out some of the other stuff. So let's start off with this. I'm going to say, according to this, a squared is equal to b squared plus c squared minus 2bc times the cosine of a. So my b is equal to 11 squared, or b is equal to 11, and then I got to square that. My c is equal to 20, and then I got to square that, minus 2 times 11 times 20 times the cosine of 112 degrees. 11 squared is 121, 20 squared is 400, and 11 times, or 2 times 11 is 22, and then 22 times 20 is 440. Cosine 112 degrees. So assuming my math was all right, I'm going to double check that now just to make sure. I'm going to say, just double check my 2 times 11 times 20. So 2 times 11 times 20 is in fact 440. So I did get that right. Now I'm going to take trig function cosine, and I'm going to do 112. Again, I haven't changed my calculator to degree mode. So I'm going to say times pi, and then I'm going to divide that by 180, and then I'm going to take the cosine of all that stuff. So the cosine of this part alone is just negative 0.3746. So that's what the cosine is. That's a 3 and a 7, by the way. It's not written very well. It's negative 0.37461. So I apologize for that looking so horrible. So I now multiply that times 440, and of course it's times negative 440, so it becomes positive, times negative 440, and now I add that to 20 squared, and I'm going to go ahead and double check, plus 11 squared, and then I got a squared is actually going to be equal to, according to my work, 685.8. Okay, so this length was just 20, and they just said units, so I'm just going to keep this as units. I'm trying to carry more than enough digits. In principle, I only have 2 sig figs, so I really should be rounding this to the nearest tenth. But that's a squared, so a is equal to the square root of a squared, and we ignore the negative because that's not a relevant distance. That's not a realistic distance. So I'm now going to take the square root of all that. And with that, I get 26.18 is the magnitude, but keeping 2 sig figs, I'm just going to say A is equal to 26 units here, and maybe I call it 26.2 just to be more consistent with what a computer's grading system is probably going to do. So now I've actually managed to work out all three sides. I've got one angle. Of course, these other 2 angles have to add to give you 180 minus 112. The idea with the law of sines is that you actually need a side, an angle, and another side, or excuse me, an angle, a side, and another angle. We can't get that right now. But now that I have all 3 sides, I could, in principle, solve for the cosine of the angle to get the other side. So let's try that. Let's try to find out what angle B is. So that's angle B. I know that b squared is equal to a squared plus c squared minus 2AC times the cosine of B, and B is what the angle B is what we want to know. So I can solve all this. I can do B squared minus A squared minus C squared is equal to negative 2AC cosine B. And now I can solve that for cosine B. And I'd say cosine B is equal to, I divide by negative 2AC. That's going to give me A squared plus B squared minus, A squared plus C squared. Let me rewrite that. A squared plus C squared minus B squared. So by dividing by a negative, I just reversed the sign of all these. I made the B negative, the A and the C positive, and now divided by AC. So the B would just be the inverse cosine of all this, which we haven't really talked about yet in our trig course, but you have a calculator button for that. It'll either say cosine to the negative 1 power, or it'll say arc cosine. So B is equal to the cosine inverse of A squared plus C squared minus B squared. So A squared, I'm going to keep that extra digit. That'd be 26.18 squared plus C squared, which is 20 squared, minus B squared, which is 11 squared. All that divided by 2 times A times C. Ooh, I left off a 2 here. So 2 times A, and A was 26.18. And C was 20. And then I'll compute all that and take the cosine inverse, and that should give us the actual angle. And then we got enough to do the rest of the triangle if we wanted, but I'm going to call it quits after that. So I'm going to do 26.18 squared minus, or excuse me, plus 20 squared. And I'm going to say minus 11 squared. And that means this whole numerator up here is going to be 964.39. And then the denominator is going to be 2 times 26.18 times 20. And that gives me, oops, got an error on that. Hold on, 2 times 26.18 times 20. I had actually done 26018 instead of 26.18. That gives me, in fact, 1047.2. So when I take the inverse cosine of that, I'm going to grab my first angle number, the 964, the 0.96, or excuse me, the 964. I'm going to divide that by the second number, which is the 1047.23, and say enter. Now I divided that and I got 0.92092. That's what this is, 0.92092. Now I'm going to take the inverse cosine of that, and my calculator is in radian modes, so I'm actually going to get a weird answer. I'm going to get it in radians, which is 0.4003497.3 radians. But let me go ahead and convert that to degrees just to make life easier. So to do that, I multiply by 180, and then I divide by pi. And that gives me 22.9 degrees. So finally, my answer is B is equal to 22.93 is what, or 94 is what I got, but I'm just going to call that 22.9 degrees. And now we have that angle, and of course we can clearly do 180 minus 112 minus 22.9 to get this last angle, and then we've got the whole triangle solved. In fact, let me go ahead and do that. That's a very simple step. So I'm going to say 180 minus 112 minus 22.93, and I get 45.07. So I'm going to say this one, C, is around 45.1. So now we've solved this complete triangle. We know A, we know B, we know C, we know big A, big B, and big C. So that's how the law of cosines is used. Pretty straightforward. You just got to remember it's the square of a side is equal to the sum of the squares of its two legs minus 2 times the product of the two legs times the cosine of the angle between those two legs. So long as you always use the angle between the two legs, you're golden. Hope that helps you better understand the law of cosines, where it comes from, how to use it, and all that good stuff.